Okay, so let's talk about slices inside of Odin and how we can work with them. So, typically speaking, when you're programming, at some point you are going to have an array of data. This could be integers, floats, Boolean values. It could even be your own special data type you've made in some type of struct somewhere. And you will want to access that information and pass it into procedures. There's a few ways you can do that in programming. You could copy the whole thing in there, or you could pass it in by a memory address. Either one would work. The copying tends to be slower, and we would like to avoid that if we can. And the memory address, while that is a great way of doing it, will start you from the first index, and then you kind of have to work your way all the way through. A slice is kind of like we're doing the memory address way, where we're passing in the index. We're not copying over the array. But it is a bit more sophisticated than that, as it allows us, as the name implies, to just take a slice of that array. We do not need to start at the first index if we don't want to. If we happen to know that the things we're interested in are in the middle or at the very end of the array, we can just pass in the memory addresses to those particular locations. So you can see down here, I have the little demonstration of what a slice is. A slice is nothing more than a pointer and a length. And you can see that if you look inside of the base runtime core.odin file, you can see the definition of what a raw slice is, and that is how they will be used throughout the program. A raw slice is nothing more than a data, which is a raw pointer, and it is a length, and that is all the struct of a raw slice is. So we have our pointer and we have our length, and this here is kind of the notation of how you will make a slice. You will have the array that you want to turn into a slice. Instead of having the slice word here, we can just say array. And then usually when you're working with arrays inside a program, you use the square bracket notation. I'm pretty sure there'll be some examples of languages out there where that's not true. But typically speaking, in the modern day, you're programming, you're going to be seeing the square bracket notation. And this is usually where we would pass in our index of the element that we want to access. But in this case, we're not trying to access an element. We're trying to determine how much of this array do we want to work with. And the way to denote a slice is in the middle of the square brackets, you add a colon. And if you just have this, just the square brackets and one colon, what that says is I want to make a slice out of the entire array. So starting at the first index, going all the way to the end. So the pointer will point to the first index of the array, and the length will be however long that array happens to be. But that doesn't have to be the case. As I mentioned, we can take slices of these arrays. So if you put a number before the colon inside of the square brackets, what that is going to do is it's going to start at that index location and then carry on all the way to the end. Now notice here, I have put the number 3 there. But remember, in most programming languages, we start at 0 when we're counting inside of arrays. So we're not getting the third index, we're actually getting the fourth element here. So in this example, we will start at the letter E in this sum data array that I have, and the length will become 7. So when we pass this slice into some procedure, or we just want to iterate through everything inside of that slice, we are going to start at the E and go all the way to the exclamation mark. The SOM will be cut off. That data will still exist inside of the array, but the slice will not be able to access it because its pointer starts here. And just like we can put a 3 in front of the colon, we can put another number after the colon. So here we have 3 and 8. Now notice there's a slight little difference here why the 3 will start us at wherever the index location of 3 is. In this example, whatever we put after the colon will be cut off. We will not access it. So even though I have an 8 here to access the, I say 8, technically the 9th because we starting at 0. What happens instead is that we stop at 8 and we get up to 7. So in this example, we will have E space DAT. That is what our slice will be able to access because the pointer will start at the E and then we have a length of 5. So 1, 2, 3, 4, and 5. The A in the exclamation mark and the SO and M will still exist in the array. That will be perfectly fine, but the slice will not be able to access that data. It is worth noting, though, that slices can manipulate the data inside of these arrays. They are pointing to the actual data itself. So if this memory isn't constant and you start messing around with these values inside of the slice, you will inevitably mess around with the data that is inside of the actual array. That could be what you want, which is great. But if you want to make sure this data stays the same, that's something to take in mind. So let's see a practical implementation of what I'm just talking about there. So let's say we have some slice. And we want to, well, let's say we have an array up here. We can see that we have the sum data, and it is an array of 10 runes. And we want to make a slice out of that array. So what we can do, and first thing first, is the simple notation is you can just do the colon equals data and then that. But if you want a more verbose way of doing it, one thing you need to remember is that the slice needs to know what type it's going to be. And you can't just pass in rune over here. What you need is to see all of my examples before I decided to do this video. If I try to run this right now, because I haven't told it it's going to be a slice, we're going to get an error. We're going to get expected operand, go to da slice. This doesn't make sense to it. And one of the reasons it doesn't make sense is because I messed up also. This is actually, I'm glad I made this mistake. Quite often, at least with me, whenever I see slices, I always forget to put the semicolon in this. Remember, if you're going to make a slice, you must include the semicolon. I always forget that myself. I'm not surprised I did it in this video. But again, we're going to get another error right now. And you will see that cannot assign the value of data, think of that as data slice, of type rune to rune. So what that means is that this isn't a slice. This is just a single rune character. Up here, we have an array. Because we have the square brackets with some numerical value inside of it, that has created an array. What we are looking for is we are looking for a slice. And this right here is kind of a subtle little difference. This means a slice, this means an array. So if we were to try to run this right now, we will see that it works. Nothing happens because we're not doing anything, but that is how you create a slice if you want to be explicit about the data type you're passing in. In most cases, you're probably going to do it like this. You're just going to do that. You're just going to do the colon with the equal sign, and Odin's going to be great, and it's going to go, you're obviously making a slice out of these runes. And just to prove that works, if I do Odin.run there, we get the exact same working result, but nothing printing out. So what can we do? Let's go ahead and we will print out, let's print out the array, and we'll also print out the slice. So if we print a new line, and we print out the data up here, we're printing out the array first. I don't know why that didn't copy. Get rid of that line. Get rid of you. Paste you in there. Now we're going to go ahead and we're going to say we're going to print out the slice down here. What you will see is we've got the exact same thing. Because over here, as I was explaining, if you do just the basic notation of a slice with the colon, the pointer to the slice will start at the beginning of the array, and then the length will be the total of the array. Now, if we go back into here and we continue with the example that we said, maybe for whatever reason we don't want the S, O, and M, but we want up to the E all the way to the end. So what we can do is we can say, I want you to start at the third index, the fourth element inside of the array. So if we print this out right now, we do Odin.run, you will see that we have some data, but just like in the example, we actually start at the E for the slice and then go all the way to the exclamation mark. So now if we go back in here, and in the other example, we saw the 8. So I believe it stops over here at the T, was that it? And we'll see when we print this out that the slice is going to become even smaller, because now it's not even pointing to the end, it's pointing kind of somewhere in the middle. And we have the sum data, but we have the E dat with a little a, because apparently I can never ever spell right in these videos. So yeah, that is kind of the example of what a slice is. Now you may notice this code down here, and I'm going to uncomment this code right now. And this is kind of illustrates that yes, in fact, all the slice is it is the pointer and it is some length. So if I also append one more line down onto here, and then I do, actually I want to just put this line, get rid of this line. I want to put this line over here. I'm just going to highlight the fact that, you know, it is a pointer and a data type. Pointer and a length. So we're going to do slice here, and we're going to wrap this in the len function, or len procedure. If you do this inside of a slice, if I can, yes, that is working, it's going to give you the length of the slice. And you can see here I'm using the transmute keyword. And you can find the transmute keyword. I think that's just implicitly available everywhere inside of Odin. But if you notice up top, I am importing the base runtime, because the raw data type over here for a slice, wherever that has disappeared to, raw slice, here we go, it is inside of the base runtime package. So I'm just importing base runtime package here. I'm giving it the alias of base. So I can say I want my raw slice to be equal to the transmuted version. So this basically allows me to access those fields inside of the struct. I'm nowhere near good enough at programming to explain why you can't just access the slice, but you can't. You have to transmute it into its raw data type. And that's the best explanation I got for you right now. I know that the keywords such as like slice and string, they're kind of implemented in the compiler themselves. They are in the code of the compiler. You won't find them in the standard libraries. That is the best of my understanding. But that is also the best of my description that I can give you right now. So what we're going to do is we're just going to print out this slice. And we're going to print out the length of the slice, and we are going to print out the data. So the data is the actual pointer of the slice. We will see where this slice begins. In this case, we've set it to begin at the index 3, at the E. And what we're doing below this, we're also just printing out the memory address of the third index inside of this array. So if I do Odin.run right now, you can see that slice is only of length 5 because we've kind of cut off both ends of that array. But underneath, the slice starts at this memory address, and the third index in that array also starts at that memory address. So that is a good way of just viewing that, yes, all this slice is, it is a pointer inside of some location in the side of the array. It could be the very beginning, it could be all the way at the very last element, but at some point we are pointing to a particular memory address inside of the array, and then the length tells the slice how far it's allowed to look inside of that array. Again, it could be allowed to look all the way to the end, or you could just cut it off at some point and only get a slice of the array. So yeah, I think that was a pretty decent explanation. Overall, maybe. Anyways, that's all I got to say on slices right now. So yeah, I'll see you in the next one.